Okay, so attached to today's lesson, there was a PDF of this completing the square flowchart. If you have the capacity to print it out in color, it would be super helpful to you because I have it color coded to show you which way to go. We'll turn the light on, maybe that'll make it a little better. I have it color coded to show you the steps. If you are not capable of printing this out, then I need you to text me or call me, and I will be glad to print you one out in color on my home printer and figure out a way that you can meet me and get it, because it will really make your life much easier, and you can use this when you take your final exam. So, completing the square flowchart. If you need to stop the video and print one out, if you didn't, if you had the capacity, if you print it out in black and white, then if you want to, you can color it looking at mine or looking at the one on your screen. But anyway, this will be very helpful to you. I've worked about 2 years tweaking this to get it exactly how I want it, and this will talk you through how you complete the square. Okay, so I would like you to have in your packet section 5. On Thursday on CUDA, you did from 212 to 221. And then on Friday, I gave you more just like that to practice, and you uploaded the answers to LMS. Today, I want to start on problems like 222. Now, if you notice, I'm just going to point at 2 problems. The squared thing has a coefficient of 1 up here. You see it? On 222, the squared thing has a coefficient of 5. A coefficient of 3. When we go to the next page, a coefficient of 7, a coefficient of 8, a coefficient of 9. So today the lesson that I'm teaching you is how you do completing the square when the coefficient is not 1. And we're going to start with problem 222. 5n squared minus 1 equals negative 10n. Okay. Alright, so I get out my flowchart and I start up here in the big orange square, and it says check the left hand side of your equation. Is it already a perfect square trinomial? And right over here I've given you the definition of a perfect square trinomial. Mine has a hole punch here, and if you print yours out, I actually typed that in. This is an old one that I've tweaked. You can see down here I've added some words too. To be a perfect square trinomial, the first term is a positive square, the last term is a positive square, and the middle term is double the product of the roots of the first and last term. And then I give you an example. Okay, 9x squared is a square, 16 is a square, that is 3x times 3x, that is 4 times 4, 3x times 4 is 12x, doubled is 24x, so that works. Okay, so starting at the orange diamond, check the left side of your equation. Is it already a PST? Nope, because 5 is not a square, and it doesn't look right. So then I go down and it says rearrange if necessary. So let's rearrange. So to rearrange, I'm going to take this negative 10n and move it over here, and it will become positive 10n. You see what I did? I moved the negative 10n over, and I just plopped it right there. I didn't move the negative 1, so it's still negative. So now I've got to answer this question. Is it a perfect square? 5 is not a square, so the answer is no, so I follow the green no. Okay, it's not a perfect square. Even after I rearrange it, it's still not a perfect square. 5 is not a square, so I follow the green no. It says move the constant to the right hand side of the equation. Throw it over. Okay, so I'm going to take this negative 1 and I'm going to throw it over. Okay, I come back to my flowchart. The little green arrow goes here. Is the coefficient of x squared equal to 1? Well, now, guys, you have to be smart enough to know that n squared is the same thing as x squared. Is the coefficient 1? No. So, diamonds, anytime you have a flowchart, diamonds are a question you have to ask yourself. So, is the coefficient of x squared equal to 1? No. So, I follow the blue. No. It says factor the coefficient of x squared out of the x squared and x terms. You will now have a number in parentheses. Okay, so let me show you what I mean by that. Take this 5 and factor it out of 5n squared. You're doing GCF. And factor it out of 10n. Now, I just said you're doing GCF, but you are not pulling out the n because you need the n in order to do the completing the square. So you're doing a partial GCF. You're doing a CF. You're pulling out the 5, but not the n. The reason you're doing that is you want this coefficient to be 1. Okay? So I pulled 5 out of 5n squared and it left me with n squared. I pulled 5 out of 10n and it left me with 2n. Okay? So here's where I am on my flowchart. Factor the coefficient of x squared out of the x squared and x terms. You will now have a number in parentheses. And I do. Now, I follow the arrow. It goes bip, bip, bip over here. And it says, divide the coefficient of x by 2 and square that number. So divide the coefficient of x, which in our problem is an n, by 2. 2 divided by 2 is 1. And then it says square it. 1 squared is 1. Okay? So I've done this step. Divide the coefficient of x by 2 and square that number. Now, since I was coming from the blue side and it has a blue box around it, I've got to follow the blue one back. Okay, because I'm following the blue path. Put that number, the one you just found right here, inside the parentheses and multiply it by the number in front. Add that new number to the other side. Okay, now let me go through that one more time. We took half of the 2, which was 1, and we squared it and we got 1. It says, if I'm looking on my flowchart, put that number inside the parentheses. So right here I put plus 1. Then it says multiply it by the number in front. 1 times 5 is 5. And it says add that to the other side. Now some of you are going to be savvy enough to understand what you just did. You didn't just add 1. You really added 5 because you put it inside the parenthesis. Okay? You have to remember to multiply it back by what's out in front. So I just did this step. Okay, let me go through it one more time. I took the thing in front of the x, which in this case is an n, which was 2. I took half of it. 2 divided by 2 is 1. I squared it. 1 squared is 1. I put it in the parentheses. I multiplied it by the thing in front. 5 times 1 is 5, and I added 5 to the other side. Okay. Now I follow the blue down. The next step says simplify the right side by combining the two numbers. This is the right side. 1 plus 5 equals 6. Now, I follow down. It says factor the parentheses by PST. So the square root of n squared is n. The square root of 1 is 1. It's the sign in the middle. Now I'm to there. And I'm to this box. Factor the parentheses by PST. I follow the arrow. The next step says divide both sides by the number in front of the parenthesis. Divide this side by 5. Divide this side by 5. And now I have n plus 1 squared equals 6/5. And I'm right here on my flowchart. Now I follow the blue arrow and it goes over and it goes up and it comes to this box. Take the square root of both sides. Put a plus or minus in front of the number on the right side so you will have two answers. So take a square root of the left and take the square root of the right and put plus or minus in front of the one on the right. Okay? So now let's write what we've got. n plus 1 equals plus or minus the square root of 6/5. We're going to talk about this in just a second. You can't have a fraction under a square root sign, but we're going to talk about that in a second. Okay. Write two baby equations, because once I came up here, I follow the yellow arrow down. Write two baby equations. N plus 1 equals positive square root of 6/5. N plus 1 equals negative square root of 6/5. Coming back to my flow chart, solve both equations, remembering to put a constant in front of any square root separated by the plus or minus. So when we move the constant over, it goes there, and it goes there. So now I have this. It becomes a negative when you move it over. My instructions say put your answer in curly braces, and it says you are finished. Except we cannot leave a square root in the denominator. Okay. We have to do something called rationalizing. Right now our denominator is the square root of 5, which is irrational. We need to make it rational. Okay. Here's how we do that. I do not know if you saw it in Algebra 1 with Miss Harris or not. So, to get rid of the square root in the denominator, I'm going to forget the negative 1 for just a minute. Okay. I multiply this by another square root of 5, and whatever I do on the bottom, I have to do on the top. The square root of 5 times the square root of 5 is 5. The square root of 6 times the square root of 5 is the square root of 30. And now I no longer have a square root in the bottom. Okay? So I have negative 1 plus the square root of 30 over 5. Over here I'm going to have exactly the same thing except with a minus. Now I've got two more steps just to make sure everything's kosher. I've got to see if the square root of 30 will break down. 30 is 2 times 15, and 15 is 3 times 5, so I can't pull anything out of that. Okay, so I can't fix that, so that's one thing that I had to check. But I don't want to write my answer in this way. I want to write my answer as one fraction. So I'm going to get a common denominator. Negative 1 is the same thing as negative 5 over 5. The reason I picked 5 is because this one had a denominator of 5. So negative 1 is negative 5 over 5. So now I have negative 5 plus the square root of 30 over 5. Negative 5 minus the square root of 30 over 5. And I'm putting them in curly brackets. Now this is a booger butt problem, and it is hard, and so we're going to talk about it again, but I just wanted you to see all the steps that come in when you've got numbers out in front. So I'm going to stop this video because that's a lot to digest, and then we'll work some more.